All right, here's the power rule for derivatives, and here's the so what. Suppose somebody gives you f of x equals x to the 27th power. Do you want to expand x plus h to the 27th power? No, you want to go f prime of x equals n to the x to the n minus 1. Done, right? So that exponent just came out to the front, and then it dropped 1, and that's it. So exponent comes out the front, drop it 1, that's your derivative. So f of x equals x to the 19th. What's the derivative? You have less than 5 seconds. It's 19x to the 18th. See? Told you could do that in less than 5 seconds. Okay, a couple of things to observe. What if f of x just equals x? Then what is f prime of x going to be? Well, let's see. Your exponent here is really 1. So I'm going to bring that out to the front and have 1x to the, now I'm going to drop that exponent 1, so it's going to be 1x to the 0 power. What's 1x to the 0 power? Why, it's just 1. Now, but here's something that's cool about that. Look at the graph. All right, here's the graph of f of x equals x. What is the slope of the line? The slope is 1. The derivative is the slope of the tangent. So the slope of the tangent at every point is 1. All right, here's another example like that that's sort of weird. Let's try to separate these a little bit. So suppose f of x just equals 1. All right, how would I do the derivative of that? How would I get f prime of it? Well, think of this as being 1x to the 0 power. All right, then bring your exponent out to the front. So I have 0, 0x to the, drop this 1. So I have 0x to the negative 1. X to the negative 1 would be 1 over x, but I'm multiplying it by 0 anyway, so I just get 0. Another interesting one to think about the graph of. What does the graph of f of x equal 1 look like? Looks like that. Here's f of x equals 1. What is the slope of the line at every point? The slope is 0. That's why the derivative is 0 at every point. See, unlike on these other graphs where what the slope is depends on the value of x. So x to the 19th, right, that's x to the 19th. You can actually sketch a graph of that. It's an odd power, so it's going to look like cube. But by the way, the higher power, what it does is it flattens it out really tight into the 0. And then after you pass 1, it's going to go up really steep, although that is, by the way, not a vertical asymptote because you can go out as far as you want. There's still going to be y values up there. All right. So in x to the 19th, the f prime tells you that if my x is 0, then the slope is 0, which we can see at x equals 0. And if my x is very near 0, then I'm going to have something near 0 to the 18th power. It's still going to be small, so it's still going to be close to 0. The slope is close to 0. But as soon as I get something a little bit more than 1, I mean, you can already look at what happens when x equals 1. All right, when x equals 1, f prime of x is going to be 19. So the slope is already 19, right? Rise over 1 of the tangent is 19 over 1 at x equals 1. And then as soon as I get to x equals 2, I have 2 to the 18th power. It's a huge number. I have no idea what it even is. It's, you know, way over 100,000. So I have a slope that's more than 100,000, you know, at 2. So that's the slope, not the value, the slope. Okay, so you have a very, very steep graph. All right, so in these functions, this is telling you the slope of the tangent to the curve depends on the value of x, and this function tells you the slope at any given point. All right, this one, because of the nature of the graph, essentially because the function is linear, the slope is going to be the same anywhere on the graph. So it doesn't matter what my x value is, the slope's always going to be 1. That is why the derivative does not depend on x. Likewise here, when f of x just equals 1, the derivative does not depend on x because the slopes are the same everywhere. Okay, now you can do more nifty things with this, which we will look at in our next video.